Hello everyone, welcome to the Minnal KEAM series 2023 last lecture session. Well, today we are going to revise probability and statistics, and with this we will be ending our revision classes. Well, tomorrow of course we are going to have a live class on the most important type of questions that are likely to appear in your exam. So of course, don't go anywhere tomorrow. And yeah, but for now, the lecture classes are finally coming to an end. So, how is your preparation going on? I hope that you guys are enjoying our mineral theme series, having the best benefit of it, and definitely understanding all the concepts and able to solve all the PYQs by now, right? So, yeah, good evening to all of you. If you are new on the channel, don't forget to subscribe. This is Sana Khan, your maths master teacher, who is going to help you in your maths preparation for your +1, +2, or your dropper batch for every competitive exam as well, right? Awesome. So, we are ready to start. Yes or no? Yes or no? Hi. Hi, hi, hi. I can see so many hi and good evenings. Welcome, all of you. Welcome. All right. So today we will be revising probability, solving a variety of questions from probability. Then we will learn about statistics, the important concepts and formulas, and solve their questions as well. Okay. Great, great, great. Medical research scientist? No, I do not have much idea about it. Because Anjana ma'am, your bio teacher, definitely has idea about it. She is related to medical line. I am related to engineering line and maths line. So I'll have more idea about that. Sorry, Drishya. Okay, guys. So if you are super duper ready and excited, let me know in the chat box and we can start. Okay, should we start? Ready? Great. Chal. Now, in probability, in your class 11th and class 12th concept, you have kind of questions which are related to PC as well, like selections and countings as well. You also have questions based on conditional probability, multiplication theorem, independent and mutually exclusive events, total probability, and just our everyday probability based on multiplication and addition concepts. Okay, and yeah, we'll also be learning about variance concept today. So let's begin. Now, first concept of class 12 probabilities, conditional probability. Now this one is important. Many questions are asked from this topic itself. Now, what is conditional probability? It says probability of happening of something when a given event has already occurred. For example, today I am going to show you a very good example of this question. So suppose I ask you guys, what is the probability of getting two heads when you are tossing two coins? Can you tell me? What is the probability of getting head and head when you are tossing two coins? Anyone, please try and tell me what will be the probability of getting a head and head. Yes, when you are tossing two coins together. Come on, try. Very easy probability concept. If you are tossing two coins, how many outcomes do you get? What outcomes do you get? Well, you get outcomes like head, head, tail, 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 head, or head, tail. There are four outcomes. Absolutely right. So what is the chance of getting a head and a head? 1 out of 4. 1 out of 4, right? But what if I tell you a condition? My condition is I tossed one coin and the outcome was head. Again I am tossing the second coin. I again want head. Now what is the probability? Now can you guess what will be the answer? So first they are telling that in the first toss, head has come. Head has come, head has come. So these two are not at all possible, because I am telling you in the first toss, head has already come. Now in the second toss, what is the chance that again head will come? So generally students will think that they are asking probability of head and head. So it is 1 by 4. But it is not 1 by 4. The answer is 1 by 2. Why? Because once you have got a head, then again the chance of getting a head is only 1 out of 2 outcomes. There are only 2 possible outcomes. Now there are not 4 possible outcomes, because there is only 2 possibility when head has already come. So that is conditional probability. Happening of event E when event F has already happened. Understood? We denote it like this: P E given F. The formula is E intersection F upon probability of F. Remember this formula, it is important. Now, one more formula is important, which is related to intersection. Please note down this formula. Probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. So generally this formula is also used in conditional probability concept. They will ask you to first find A intersection B, then you find A given B. Okay? Alright. So that is conditional probability. Conditional probability is very simple. You want one more example? One simple example is, I tell you that what is the probability of getting a 6 on a dice when 1 has already occurred or 6 has already occurred? What is the probability of getting a red ball when a red ball has already taken out from the bag? So like that, condition is applied, because in your bag, if you have only 3 red balls, suppose. Now I am saying that what is the probability of getting a red ball when 1 red ball is already missing? So that is conditional probability. Now your probability will change. Now it will be 1 out of 2. It will not be 1 out of 3. Understood? Yes, you can ask doubt. Okay. Next is multiplication theorem. Now this theorem is again very important. Why? Because when two things are happening simultaneously together. For example, if I ask you, there is a 52 cards deck. From the deck I am taking out 1 king and I am taking out 1 ace. What is the probability that I am taking out a king first and then I am taking out an ace? What is the probability? Now this is multiplication theorem. Why? Because whenever AND concept is applied, it is multiplication concept. Why? Because we have to multiply the theorem, then only we will get the total number of possibilities of king and ace. Okay? Yes, maths will come on the same pattern of last year. So, what is the formula for multiplication theorem? It is just probability of A intersection B is probability of A into probability of B given A. So, this is the formula, but the concept is simple. What is the probability of getting an ace and a king? Now, the probability of getting a king is 1 out of 52. What is the probability of getting an ace when king is already taken out? 1 out of 51. Why? Not 1 out of 51. Sorry, my bad. 4 out of 52 and 4 out of 51. Now, why 51? Because 1 card is already out. Inside, we have only 51 cards remaining. This is multiplication theorem. Understood? I mean, last 3 years, before that, it was very difficult. Of course, the pattern changes. See, we cannot expect that in KEAM exam same pattern will be followed. Do you guys know that in some year they ask lots of questions from integration? In some years they ask lots of questions from differentiation. Sometimes they will ask lots of questions from complex number. So actually KEAM is not having any fixed particular pattern like only this is important. There are a number of chapters which are important, which I have already told you so many times. So among those chapters, questions will come. Of course. Now, will the questions be very difficult? No. I am definitely sure that questions will be easy to medium level. They will not be very difficult level. So don't worry. Okay. Next is independent events. Now this is also important. Everything is important. Probability. It is very small chapter. So everything is important. Now what is independent events? If two events are happening together, but they are independent of each other. For example, if one event is coin toss and another event is dice roll. Now, if you toss a coin and if you roll a dice, the outcome is independent. Here tail can come, here 6 can come. Anything can happen. They do not depend on each other at all, right? So, these type of events are called as independent events. Now, what is unique about independent events? Well, their intersection is always equal to PE into PF, probability of event E into probability of event F. This is important formula. Another, their conditional probability is also different. Probability of F given E is equal to probability of F because they are independent. So even if E has happened, I don't care. I will only find the probability for F if it is independent. Okay. Next, total probability. Now what is total probability? When many events are happening together and there is one major event which depends on all of them. So then we have to find out total probability. Now how do we find out total probability? It is nothing but multiplication theorem of all the events happening together. So what we do? We multiply the probability of happening of event E with probability of A given E1. Similarly, E2 with A given E2. En with A given E1. So it is sum of all of the basically probabilities of happening of that event. Okay. Now, probability distribution of random variables. This is also there. I guess this is the last topic of your probability chapter. Now in random variable, what happens? Suppose there is a variable which is taking different values x1, x2 and so on, xn. And it has different probabilities p1, p2 and so on, pn. Then the probability distribution is given like this. So we have two formulas related to this. The above probability distribution is defined only when each of the probability is greater than equal to 0 and summation of all the probabilities is always equal to 1. That means what? If you add all of them, you will always get 1 as your answer. Question is asked from this concept. If they give you random variable, if they give you probability associated to random variable, you can add all of them, the answer will always be equal to 1. Okay. Next, Bayes theorem concept. Now what is Bayes theorem? Bayes theorem says, what if we want to find out an opposite thing? For example, let's take two bags. There is bag number 1. Okay. And then there is bag number 2. And in this bag we have red ball, blue ball, red ball, blue ball. Here also we have red ball, blue ball, red ball, red ball, blue ball, like this. Now I'm saying that if I ask you, what is the probability of getting a red ball from bag 1? You will say 2 out of 4. What is the probability of getting a red ball from bag 2? It will be 3 out of 5. This will be 2 out of 4. Fine, that is easy. But what if I ask you, from the 2 bags, I am taking out a red ball. You tell me what is the probability that this red ball was from bag 1. The entire question is like flipped. Now I am not asking that What is the probability of red ball? What is the probability of blue ball? I'm not asking that. I'm saying that red ball is already there. I don't care what is the probability. I want to know this bag is from bag number 1 or bag number 2. This ball is from bag number 1 or bag number 2. How we will find that? For that we have Bayes theorem. Okay. So example, suppose you want to find out that the probability of selecting bag number 1, given that red ball has been taken out, it will be equal to what is the probability of taking out red ball from bag 1 multiplied by probability of bag number 1. Similarly, total probability of taking out a red ball from bag number 1 or bag number 2 or bag number 3, however bags are there. Okay. So, here we find reverse. If you know the probability of getting a red ball from bag 1, you can find the probability of getting to know basically bag 1 was selected when red ball is already taken out. Okay, it's quite twisted to understand, but yeah, that's Bayes theorem. Now, let's see what kind of questions can be asked from probability. Let's solve all of them. You guys also try solving the question along with me. Answer whatever you feel. Let's see whether you are able to approach the question or not. Okay, first question. A bag contains 5 yellow, 3 green, 2 blue, 7 white balls. If 4 balls are chosen at random, probability that none of them are white. What will be the probability that none of them is white? The probability will be C. A simple formula for calculating probability is ignore white balls. Count all the other balls. So apart from white balls, how many balls? 5 plus 3 plus 2. How many balls are there? 10 balls. So from 10 balls, I am selecting 4 balls because I have to select 4 balls. So basically, from these 10 balls, if I select 4 balls, they will not be white because it is asking none of them should be white. Simple. Now, what is the total possible outcome? This is my favorable outcome, right? Now, I want to know what is total possible outcome. Total possible outcome is simple. Total number of balls are 10 plus 7, 17. So, 17C4. This is my answer. Now, you can simplify it. So, 10C4 upon 17C4 is equal to 10 factorial upon 6 factorial into 4 factorial divided by 17 factorial upon 13 factorial into 4 factorial. Let's simplify this. 10 factorial can be written as 10 into 9 into 8 into 7 into 6 factorial upon 6 factorial into 4 factorial multiplied by 13 factorial into 4 factorial upon 17 into 18 into 19 into, what am I writing? 17 into 16 into 15 into 14 into 13 factorial. So 13 cancel, 6 cancel, 4 factorial cancel, right? Yeah. So we get finally 10 into 9 into 8 into 7 upon 17 into 16 into 15 into 14. That's your answer. Okay. No, blind master, it will not be just 10C4. It will be 10C4 divided by 17C4. Alright, so your answer is 3 upon 34. When you simplify, you'll get 3 upon 34. Understood? Next question. An urn contains 25 marbles which are numbered from 1 to 25 and a marble is chosen at random 2 times with replacement. Then the probability that both times the marble has same number is dash. What will be the solution of this question? Think about it. How many favorable outcomes are there for getting same number? Simple. If let's talk about probability of getting same number is basically favorable outcome upon total outcome, right? Now, what is your favorable outcome? Your favorable outcome is you should get same number on both the marbles. Same number on both the marbles. So how many possibilities are there? There are 25 possibilities, right? Either 1 1 will come, 2 2 will come, 3 3 will come, 4 4, 5 5 and so on, 25 25. So how many favorable outcomes? 25 favorable outcomes. Out of total possible outcomes. Total possible outcomes are, in the first ball, you can have 25 outcomes. In the second pick, again 25 outcomes. So your answer is 1 upon 25. This is the solution. Okay? Because they have written with replacement. Correct? Yes, you are right. 625 is the total outcome. Very good. Next question. If A and B are two events such that probability of A is given, probability of B is given, probability of A intersection B given, they are asking probability of B intersection A complement. Now what is B intersection A complement? It basically says that B should be there but A cannot be there at all. Right? So what does that mean? It means that probability of B intersection A complement will be nothing but probability of B minus probability of A intersection B, because it is saying that they want common between B and not A. So not A is nothing but B, and since A should not be there, so you have to subtract A intersection B. So what is probability of B? 0.55. What is A intersection B? 0.1. When you subtract, what do you get? 0.45. This should be your answer, right? Hi Dia, welcome. Understood or not? What is B intersection A complement? A complement is A should not be there. So just subtract A intersection B. If you subtract A intersection B, A is removed. So it is PB minus P intersection B, 0.55 minus 0.1. Okay. Moving on. Two dice are rolled if A is the event that sum of the number is 4 and B is the event that at least one of the dice shows a 3. Then what is A given B? This is conditional probability. Conditional probability question has come. Okay. Now, let's have a look. What is the probability of A? Let's first think about A. Now, A is what? It is the event that sum of the number is 4. How many events are possible? Tell me. Either 2 2 or 1 3 or 3 1. So total 3 out of 36 outcomes are possible. Why 36? Because 2 dice, 6 into 6, 36. So 3 out of 36 outcomes. Fine. What is the probability of B? Like, in how many chances at least one of the dice will show 3? So forget about probability. Let's look at the set of B. So B has many possibilities like 1 3 2 3 3 3 4 3 5 3 6 3. Then 3 1 3 2 3 4 3 5 3 6. Right? Yeah. So total how many? 1 2 3 4 5 6 7 8 9 10 11. 11, not 12, blind master. We will not count 3 3 2 times. We will not count 3 3 2 times. It will be only counted one time. So probability of B is 11 out of 36. But what is my question? My question is saying that what is the probability of happening of event A when event B has already occurred? Karuna is saying option D. Well, option D is not the right answer. Do you know why? Because it is conditional probability. Now, what is conditional probability? It is saying that sum of the number should be 4 when one of the number is 3. What is common between them? Just think what is common between them. See, probability of A given B is probability of A intersection B upon probability of B. What is probability of A intersection B? A intersection B means that sum is 4 when one of them is 3. Now, can you tell me how many such outcomes are there when the sum is 4 and one of the number is 3? Only 2 such outcomes, 1 3 and 3 1. Okay, so it is 2 out of 36 divided by 11 out of 36. What is your answer? 2 out of 11. Now you understood how we are doing conditional probability. These are the events where sum is 4. These are the events where 3 is appearing. But we want intersection of them. So common is 1 3 and 3 1. There is nothing else common. 1 3. Here also 1 3. 3 1 3 1. Only 2 events are common. So 2 out of 36 upon 11 out of 36. So 2 out of 11 is the answer. Understood? Okay. Next question. If A and B are mutually exclusive events such that probability of A is given, A union B is given, probability B is equal to what? Now, why is it 11? Oh, blind master is still stuck. Let me show you again. Why is it 11? See. Just count it like this. Okay. The B is saying at least one of the dice shows 3. At least one time 3 should come. 3 will come how many outcomes? 3 1, 3 2, 3 3, 3 4, 3 5, 3 6. Okay. 1 3, 2 3, 4 3, 5 3, 6 3. Now you guys are not understanding that here 3 3 is there. Again 3 3 will not be counted. You cannot count 3 3 2 times. Why will you count 3 3 2 times? Because 3 3 and 3 3 both are same thing. They are not different outcomes. They are not different outcomes. They are same outcomes. So you cannot count it 2 times. Just count it 1 time. Yes. Okay. So it is 2 out of 11, not 12. Okay. Now coming to this topic, one important term has come. Mutually exclusive events. What are mutually exclusive events? Please note down. Events that cannot happen together. They cannot happen together. Cannot happen together. This implies probability of A intersection B is 0. Always. If they are mutually exclusive events, their intersection is 0 because they cannot happen together. Very good, Karuna. So here, I told you one formula for A union B. What is the formula? Probability of A union B is probability of A, probability of B minus probability of A intersection B. Now, probability of A union B is 0.75. Probability of A is 0.5. Probability of B is we don't know, minus 0. Just find out probability of B. Shakti, very good Shakti, absolutely right answer. 0.75 minus 0.5 is 0.25. This is your answer. Everybody understood now? What are mutually exclusive events which cannot happen together? So their intersection is always 0. Simple. Okay, that's your answer. Next, a jar contains 7 black balls, 6 yellow ball, 4 green ball, 3 red ball. All of them are of same size and weight. If a ball is drawn at random, then the probability of the ball being red is dash. Please answer this question. Please, I want you guys to answer this question. It is very, very, very easy. You don't have to apply any extra logic. Very easy. Please answer this question. Everybody, just try answering this question. There are 7 black, 6 yellow, 4 green, 3 red balls. They are asking, what is the probability of getting a red ball? Come on, answer. Blind Master B, Rifa B, Shakti Singh D. Anybody else who wants to try? Come on, yeah, try answering the question. What will you do in your KEAM exam? Yes, Sanju. Yes, Malvika. Absolutely right. It is so easy. 7 plus 6 plus 4 plus 3 is 20. And number of red balls are 3. So your probability is what? Your probability of getting a red ball is 3 out of 20 balls. That is so easy. Such a basic level question that is like 10 seconds ka answer. 3 out of 20 is our answer. That is so simple. Isn't it? Yes, very good. Again, very interesting question. 3 dice are rolled simultaneously. ABC is the outcome on the top of the dice. Probability that the minimum of ABC is 6 will be dashed. Try answering this question. Come on. Come on. Try answering this question. Minimum of ABC is 6. What is the probability? Basically, what is ABC? ABC is the outcome. A, B, C is your outcome. Outcome can be anything. It can be 1, 1, 1. It can be 1, 2, 1. It can be 6, 2, 1. It can be 6, 4, 2. It can be 3, 5, 6. Anything. It can be anything. So, I'm just asking, what is the probability that the minimum of the 3 outcomes is 6? Minimum is 6. Blind Master is saying option A is the right answer. So, now, if you observe, if I have my outcome 1, 6, 5, what is the minimum value? Minimum value is 1. If my outcome is 6, 6, 4, what is the minimum value? 4. So, always the minimum value will be less than 6, right? Always the minimum value is less than 6. So, in what situation minimum value will be 6? Only when you have 6, 6 and 6. What is the minimum of 6, 6 and 6? 6, right? So, only in this situation I am getting minimum at 6. Apart from this, every other situation I will get less than 6. Why? Because in the dice you have 1, 2, 3, 4, 5, 6. Every number is less than 6. You don't have 7, 8, 9. You don't have these numbers. Every other number is less than 6. So if you want minimum 6, all the 3 numbers should be 6. So the right answer is 1 out of 2, 1, 6. Why? Because only one favorable outcomes, and this is favorable outcome, and total outcomes are how many? Total outcomes are 6 into 6 into 6. 2, 1, 6. Now you understood why is it coming 1 out of 2, 1, 6? Because there is only one possible situation. Alright, next question. If A and B are 2 events such that probability of A is given, B is given, A intersection B is given, probability of A given A union B. Simple. First you find out what is the probability of A union B. A union B is probability of A plus probability of B minus probability of A intersection B. Probability of A 0.5, probability of B 0.4, probability of A intersection B 0.2. So this is 0.9 minus 0.2 is 0.7. Now they are asking probability of A given A union B. So this is simply probability of A upon probability of A union B. Probability of A is 0.5, probability of A union B 0.7. What is the answer? 5/7. Option C. Okay. Understood? Understood? Everybody? Cool. Next question. Super easy question. Come on. In 10 seconds, your answer should come. Everybody answer this question. There are 37 men and 33 women at a party. If the prize is given to one person at random, probability that the prize goes to a woman is dash. Very good, Shakti. Super fast, super quick. That is an easy question. Price going to a woman. So, the probability will be favorable outcome upon total outcome. Favorable outcome, how many women? 33 women. Total outcome, 37 men, 33 women. So, it is 33 upon 70. Simple, right? Easy. Option A is the right answer. How quick, how easy is this question? So from probability, not every question is logical. Some questions are very direct, very direct, very basic for probability, logic based question. Okay. So not every question is difficult, so don't worry much. Moving on. Next question. A fair coin is tossed twice. This is the question of conditional probability, which I was telling you earlier. A fair coin is tossed twice. Given that first toss resulted in head, then probability that second toss also results in head. Now, whenever you toss a coin 2 times, what happens is you get head, tail, head, head, tail, head, or tail, tail. Now they are saying in the first toss, head has already come. So now my outcome has reduced to head tail or head head. So my answer is 1 out of 2, not 1 out of 4. Okay. It will be 1 out of 4 when we are tossing it together. It will be 1 out of 4. But they are not tossing it together. They are saying that I am tossing one coin, I am getting a head. Again I am tossing second coin. Now I am getting head or not. So it will be just 1 out of 2 because head is already fixed. This is already fixed. So this is not possible. Understood? Yes. So this was the example I was giving you earlier for conditional probability. It is a KEAM PYQ question. Okay. Awesome. So option D is the right answer. Very good. Travel world. Next question. Very good. Very interesting question. Everybody read it carefully. An urn contains 9 balls, out of which 3 are red balls, 4 are blue balls, 2 are green balls. 3 balls are drawn at random without replacement from the urn. The probability that the 3 balls have different color is dash. Now for this, of course, if we sit and we find probabilities of getting a red, getting a blue, getting a green, then dividing by total outcome, it will be a long task. So what we can do here, we can use here combination concept. How come? So since we know that out of 9 balls, we are taking out 3 balls. Out of 9 balls, we are taking out 3 balls. So this is total possibility, total possible outcomes. That from 9 balls, I am taking out 3 balls. That is my total possible outcomes. But what is my favorable outcome? My favorable outcome is all the balls should be of different color. That means one ball should be red, one ball should be blue, one ball should be green. What is the probability of getting a red ball? 3C1, blue ball 4C1, green ball 2C1. So from here I got my probability as 3C1 into 4C1 into 2C1 divided by 9C3. When you solve this, you will get 2 out of 7. Okay. So basically, they are asking that all the 3 balls should be of different color. If you want balls of different color, then you have to basically know that first ball is red, second ball is blue, third ball is green, or blue, green, red, or green, red, blue. Some combination like that. Okay. How will you get combination? Using combination concept. So 3C1, 4C1, 2C1, these are the combinations possible. Out of total number of combinations are 9C3, because from 9 balls you are selecting 3 balls. That's your answer. Okay, people, understood? Cool. So 2 out of 7 is your correct answer. Next question, very interesting question. I want all of you to try this question. There is a box which has 4 marbles, 1, 2, 5, 10 is written on it. 1 marble is selected 4 times with replacement. Then the number on it is noted. What is the probability that the sum of number is equal to 18? Now, how will you get 18? First think, how is 18 possible? Say, 1 plus 2 plus 5 plus 10 is 18. Nice. Any other combination possible? Any other possibility that, is it possible that 10 plus 5 plus 5 plus 1 is 18? No, not possible. Any other combination possible? No. So what I observed, that only when one ball is 1, one ball is having 2, one marble is having 5, one marble is having 10, only then 18 is coming. But then there are many chances. Chances in the sense, it is not necessary that you will get 1 to 5, 10. You can get 10, 5, 2, 1, or 10 to 5, 1, or 1 to 5, 10, 5, or 2, 1, 10, 5. There are so many possibilities. It's not compulsory, na? On first ball, 1 will come, or 10 will come, or 2 will come, or 5 will come. How do you get that answer? It is a simple permutation and combination concept. Do you know how to apply that concept? How many of you know? It is very simple. See, if you have 4 digits, it's like a digit question. If you have 4 digits and you have 4 numbers, 1, 2, 5, 10. You want to know how many total possible digits, numbers are possible. Very good, others. The simple answer to this is 4. In the first box, 4 digits can come. Any 4. In the second, since 1 is selected, only 3 can come. In the third, since 2 numbers are already selected, only 2 is left. And last, 1. So the answer is basically 4 factorial. So therefore, your favorable outcome is 4 factorial, 4 into 3 into 2 into 1. Because in how many outcomes 18 is coming? 18 is coming in these many outcomes. In these many combinations, 18 can come. Now divided by total outcome. Now what is your total outcome? Total outcome will always be, in the first chance, 4 possibility. In the second pick, 4 marbles. Third pick, 4 marbles possible. Fourth pick, 4 marble possible. So your answer will be 4, 3, 2, 1 divided by 4 into 4 into 4 into 4. 4, 4 cancel. 2, 2 is a 4. So you get 3 out of 32. This is your answer. 3 out of 32. Okay. Because your favorable outcomes are 4, 3, 2, 1. And your total outcomes are 4, 4, 4, 4. Now this is a very logical question. This is a very logical question. Okay. Now we are not applying any formula to it. We are just applying the logic. The logic is, my sum should come 18. 18 is coming only when the combination is 1 or 2 or 5 or 10. Now, how many combinations are possible? That is 4 factorial. 4 number, so 4 factorial. Divided by total outcome. Total outcome is always in the first pick. There are 4 possibility. Again, 4 possibility. Again, 4 possibility. So, therefore, your probability will be this. Understood, everybody? So, you are getting 3 out of 32. Alright, next question based on random variable x. Okay, now the question is saying that the probability distribution of a random variable is given, then the expectation of x is dash. Now to find the value of expectation of x, first you should know what is a here. How can we find out the value of a? Simple. I told you summation of pi is always equal to 1. All the probability sum is always equal to 1. So a plus 2a plus 3a plus 4a plus 5a is equal to 1. So 5 plus 4, 9. 9 plus 3, 12. 12 plus 2, 14. 14 plus 1, 15. 15a is 1. So a is 1 upon 15. Now they are asking what is the expectation of x. Now expectation of x is given by summation of xi into pi. So you multiply this, multiply this, multiply this, multiply this, multiply this. What do you get? Minus 1 into a, minus a. 0 into 2a, 0. 1 into 3a, 3a. 2 into 4a, 8a. 5a into 3a, 15a. How much is this equal to? Calculate. 15 plus 8 is 23. 23 plus 3 is 26. 26 minus 1 is 25. Very good. 25a. But this is not my answer. I know the value of a. What is the value of a? 1 upon 15. Put it over here. So this is 25 into 1 upon 15. 5 5s are 25. 5 3s are 15. So 5 upon 3. That is your answer. Okay. Everybody understood? Summation of probabilities is always equal to 1. So we got the value of a. Then expectation of x is summation of xi into pi. So it is basically this into this, this into this, this into this, this into this, this into this. Add all of them. You get 25a. A is 1 by 15. So you get 5 by 3. Okay. Open hype. Yes, welcome. Alright. So guys, from probability, these are the variety of questions can come. Questions can come from conditional probability, multiplication theorem, independent event, mutually exclusive events, sometimes total probability, and the last one, random variable, also can come. Also, most of the times, some basic probability concept based using the combination and permutation concept also comes inside. Alright, moving on to statistics. Now statistics is an easy chapter. It is almost always formula based. So let's look at the formulas. Number 1, the measures of central tendency. How many of you know about mean, median and mode? How many of you are confident about mean, median and mode? Mean is the average value. Median is the middle value. Mode is the most repeated value. All of you know that? Okay. How do you calculate mean? Mean is sum of all observations divided by number of observation. Sum of all divided by number of observations. That is mean. What is median? Middle value of the arranged data. If you arrange your data in ascending or descending order, the middle value is the median, and mode is the data point that has maximum frequency. All of you know that? Okay. Next, there are some important properties of mean. What are they? Number one, if you add, subtract, multiply or divide some constant to the resultant mean, then some constant to each number, then the resultant mean is also added, subtracted, multiplied or divided by the same constant. Okay. So suppose we are finding mean of 10 observation. You multiply each number by 2. Then your mean will also be multiplied by 2. Nothing else. Directly you can tell. Okay. Next, if you are calculating deviation of each value from the mean, then the sum of deviation will always be equal to 0, because your mean and your medians are almost middle values. So if you subtract all observation from mean, then some values will be positive, some values will be negative, total will always be 0. Okay. Next, this is also important. It was asked in the KEAM PYQ. The mean of two groups of same unit of measurement is given by, suppose you have two different observation and in both the observation they give you mean. Suppose n1 observation mean is x1. For n2 number of observations mean is x2. Then the total mean, this is total mean. Total mean will be n1 into x1 mean plus n2 into x2 mean upon n1 plus n2. Okay, these are the properties of mean. Now let's come to deviation. What is deviation? It is calculated about a central value, either mean or median. They will write in the question. So A is what? A is either mean value or A is median value. One of them. A is either mean or median. So the mean deviation formula is summation of mod value of xi minus a. This is deviation. Summation of the deviation, sum of all deviations divided by number of observations. Now if frequency of each observation is given, then it is summation of fi into xi upon summation of fi. That is mean formula. We have learned it in class 10th also. Next, variance and standard deviation. What is variance? Variance is summation of xi minus x mean whole square divided by n, which is equal to, please remember this formula, it was asked in KEAM PYQ. All the formulas are important, okay? Variance of x is summation of xi, that is summation of each observation square divided by n minus summation of xi upon n whole square. Both the things look same, but they are different. Okay, they are not same. Next, if you know variance, you can calculate standard deviation. Square root of variance is standard deviation. There are some more formulas for it. I will tell you. First, some properties of variance. Variance of x plus constant is simply variance of x. Constant is removed. Variance of c into constant is c square into variance of x. Remember, it's a very important formula. C square into variance of x. Variance of ax plus b is a square into variance of x. How come? Because addition is removed, multiplication is square. So a square into variance of x. Okay? Cool. Lastly, what is coefficient of variation? Coefficient of variation is your standard deviation upon mu into 100, and standard deviation is root over summation of xi minus mu whole square upon n. These two formulas also were asked in KEAM exam. So all the formulas I have listed here, everyone is important. You cannot leave any formula. Okay, let's solve some question based on statistics. Question number 1. Assume that n distinct values occur with frequencies given where mean value is 7, Summation of fi xi is 315. Summation of fi is equal to what? Simple. This is mean formula. Mean formula is what? Summation of fi into xi upon summation of fi. This is mean formula. Mean is already given in the question. 7 fi xi 315. Summation of fi asked in the question. So summation of fi is 315 upon 7. How much is 315 upon 7? Calculate. 7 4s are 28, 7 5s are 35. So 45 is the right answer. Okay? 45. Clear? Next. The variance of a data with summation of xi 650, summation of xi square 10,000 is dash. Just now we have seen variance formula. What is the formula for variance? Variance is equal to summation of xi square upon n minus summation of xi upon n whole square. So it is, now what is xi square? 10,000 already given in the question. 10,000 divided by what is the value of n? N is 50 minus summation of xi upon n whole square. So it is, what is xi? Summation of xi 650 divided by 50 whole square. So this is 5 13 and this is 5 2s are 10, 200. So we are getting 200 minus 13 2s are, no, 13 square 169. So 200 minus 169 is how much? 31. This is your answer. Just in the formula we are putting values, nothing else. Direct formula based question. We are taking the formula, we are putting the value, we are getting the answer. Understood? Next question. If x is a random variable with expectation 6, variance 3, then expectation of x square is equal to dash. Now for this, there is a formula, very direct formula, note it down. Variance of x is expectation of x square minus expectation of x whole square. Now this is what? This is nothing but summation of xi square minus summation of xi upon n whole square. Just now the formula which we have seen, it is another way of writing it. So what is ex? Ex is basically summation of xi square upon n. Understood? Just put the value. So we have ex is given 6. So put ex as 6. Variance is given 3. Put variance as 3. And e of x square can be taken out. 3 plus 36, 39. Simple. Okay. Clear? Just now the formula which we have seen, this formula. This formula and that formula are simple. From this formula only, variance of x is expectation of x minus expectation of x whole square. This is the same formula we are using here. Okay, next question. Yeah, we have got 39 from here. Next question. Coefficient of variation, mean of distribution are given 75 and 44. Then the standard deviation of distribution is dash. We have seen a formula. What is the formula? The formula is coefficient of variation is basically equal to sigma upon mu into 100. Remember? So here mu is nothing but your mean distribution. Sigma is asked in the question. They are asking standard deviation, so they are asking sigma value. So just put everything in the formula. Variance is given 75, sigma is unknown, mean is given 44 into 100. So sigma is equal to 75 into 44 upon 100. Simple. Okay. Alright. Again, this is formula based question. Variance is given, mean is given. They are asking standard deviation. Direct formula based question. So 33 will be your answer. Again, very interesting question, very simple question. In an examination, 20% of the students score 70 marks. 40% of the students score 80 marks. 30% of the students score 90 marks. And rest score 100 marks. Then the mean score of the student is how much? So, total mean question. Total mean. What is the formula for total mean? Total mean is x1 mean into n1 plus x2 mean into n2 upon n1 plus n2. That formula we will use here. So they have given n1 20%, n2 40%, n3 30%, n4 10% of the students. Next, they have given mean value, how much they have scored 70, how much they have scored 80, 90, 100. Just put it in the formula n1 x1 plus n2 x2 plus n3 x3 plus n4 x4 upon n1 plus n2 plus n3 plus n4. Done. Put everything in the formula. Your answer is 83. Simple. Okay. Everything is formula based in statistics chapter for sure. Alright guys, so from statistics chapter they generally ask very less questions, 2 or 3 questions only. So these were the only variety of questions I could find on the KEAM PYQs. But yeah, we have practiced a lot of variety, so it will be definitely, you will be able to solve any type of question that comes. So guys, today we have completed our revision. Tomorrow we are just going to practice and see the most repeated, most important PYQ. So, well done. Congratulations that you have come so far. You have prepared so much and you have done so much of hard work for your KEAM exam. Now, I have full faith on you that you are definitely going to rock this year in your KEAM exam because you have done so much of preparation with us with this Minnal KEAM series. Thank you for joining today's lecture and every day as well, and putting us so much time on the Minnal KEAM series and trusting us. Thank you so much for that. Also, if you want to continue studying for your +1, +2 or your dropping batch or your competitive exam, do subscribe to the channel. And if you enjoyed today's video, do hit the like button. Thank you for watching. Have a wonderful day. I will meet you tomorrow 6 p.m. Okay? Tomorrow the class is at 6 p.m. We will have a live class. We will discuss the most important, most likely questions so that you have a good idea of how your paper will be. Alright. Thank you for watching everybody. Take care. See you tomorrow. Bye-bye. Bye guys. Bye.